My name is Stratos. I'm co-founder of WeatherXM, where I lead the engineering team. And we're here today to talk about how compute on weather meets COD, compute on data, or cow meets code. Sorry, I couldn't help it. This is Dali's impression of this meeting. So at WeatherXM, we're building the world's largest and fastest growing weather network. We have sold more than 5,000 weather stations worldwide, and we only started less than a year ago. And we have more than 9,000 members on our Discord server. So you may think that weather is a solved problem, and you would be wrong, of course, because still, we lack accurate weather data for historical weather data, current weather conditions, and forecasts. And let me give you just a small example of the size of this problem. So this is a 3-day ahead forecast for Lisbon last week. And we can see the bold blue line is what happened in reality for temperature and the top chart, and precipitation at the bottom. And the other lines are the weather forecasts from 5 different models, 5 different mobile apps, let's say in the weather. So what we see here is that for the first hours of the forecast, they're pretty accurate, okay. But as the forecast goes on, then we can see up to 5 degrees Celsius difference in temperature compared to the reality. And for rain, for precipitation, it's even worse. There are models suggesting that there would be no rain, and others that it would rain up to 3 or 4 millimeters, which is moderate rain. But in fact, it only poured like 1.2 millimeters. So still, one might say this is a small problem for everyday people that just want to know if they should take their umbrella or not. But in fact, it's a huge problem for so many industries like agriculture, supply chain, energy, and so on. And this is why governments across the globe keep spending billions of dollars just to forecast the weather and monitor current weather conditions. And it's still one of the hardest problems for humankind. So we believe new approaches are necessary to solve this problem. Inspired by Filecoin and Helium, we embraced their economic models and took advantage of their existing infrastructure to build a better weather network. So we are utilizing Filecoin to store weather data, and lately experimenting with computation. And we hope that this will help us solve our mass-scale data storage problems. And we're also utilizing Helium network for connectivity, network connectivity for one of our weather stations. And all these new technologies enable us to build this new weather economy around weather data with our WXM token in the center. So station owners earn WXM tokens for their weather data contribution to the network, and customers who require weather data and services can purchase them using WXM tokens. For this to work, we had to build our own brand new Web3 native weather stations. They have a number of improvements compared to the traditional weather stations, let's say. They are energy and communication autonomous. They're 10 times more affordable, and they provide cryptographic proof on the weather data. And our customers are already taking advantage of this new hardware to get improved weather forecasts on their mobile apps and our web apps. So we have already shipped 3,000 of these stations, and we're about to ship another 2,000 in the following weeks. And we're ramping up production to meet the high demand, and we estimate to have produced 11,000 by the end of 2022. Just to compare this number, NOAA, the US Met Office, operates currently about 14,000 weather stations across the US, and they've been around for like 50 years. So you can imagine that very soon we're going to produce tons of data. That's why we started experimenting with compute over data technologies. So compute over data in a Web3 distributed way, and Bacalhau project, to be more specific, promises scalable, cost-effective computation, offering also parallel workloads, and we can benefit from that with public, transparent, and verifiable computations. And this makes so much sense for us in so many ways. There are critical components of our network that can benefit, like the token reward system, which is backed by quality of data mechanism and proof of location. For these mechanisms, transparency and verifiability are key. And also for our weather forecasting engine, we can benefit from distributed data aggregations and distributed forecast model training and execution in a very cost-effective way. So it's demo time. Our team, with an extensive experience of more than 48 hours using Bacalhau. Let me just show this as well. So we prepared a very small demo, just to explore what's possible with Bacalhau. Forecast accuracy tracking is very important for us because it's the first step towards an improved weather forecast. Because how can you improve forecast if you don't measure the accuracy of existing forecasts before, right? So just for this example, we have two data sets of data for two locations. One is in Lisbon for October, and one is somewhere in the UK. And we have actual conditions, hourly data sets from two of our weather stations for these locations, and forecast time series from three different weather models. And we've also prepared a Docker container that's running just the basic RMSE calculations, comparing forecasts and actual conditions, and doing also some other correlation stuff. And the goal here for this demo is to find for these two locations which forecast provider or which forecast model is more accurate for temperature, humidity, and wind speed. So we're going to see this in practice, running first for one of the locations and then utilizing parallel workloads to run both locations at the same time. Okay, so let me cheat a bit and copy the command here. So we have already uploaded data on IPFS. I can actually try and show it to you. Right. So let's try Lisbon first. So we have the observation data from our stations, just basic hourly CSV file. And similarly, for the three forecasting models, you can see, again, hourly data. Okay, so basically here we're asking Bacalao to run a Docker container that's already up there on GitHub. I'll give you a public link for it to download if you want. And run this Python file where it produces some calculations on the data, comparing forecasts and historical data. Yay. That was easy. Now we have the result. All right. I should stop this IPFS first. Let's get the job results. By the way, you need to fix that, right, on Bacalao? It's a good one. Yeah, I have more suggestions for you guys. So let me find it. It's in the outputs folder. Okay, Lisbon. And let's just try temperature. Okay, so this was produced by the Docker container, and what we can see here, let me just zoom, is that again, the bold line, the black line is the actual conditions, and the rest are the forecasts. So we can see that, oh, and by the way, this is all day ahead forecasting. It's not like 3 days in the future. For every day, we got the hourly forecast for the day. So one would assume that, especially for temperature, I mean, how hard would it be to measure temperature? Well, apparently it is. And they're not doing a good job even with temperature. You see at some days, like here, they're off like 6 degrees Celsius, some of the models. And for days, like, I mean, for most of the days, even if the models are inaccurate, you can see that the temperature pretty much follows, you know, a classic line that you would expect, but a classic curve. But this is a nice example, this area here. So like near the 19th of the month, we had some rain coming. Let me just show you something else. Our meteorologist, Stavros, said I should show you this map. Thank you, Stavros, if you're watching us. So you can see this phenomena just to the west of Portugal, which affected apparently forecasting because the actual weather, the actual temperature didn't even follow the expected curve, but models could not model it correctly. So the situation is pretty similar with the others as well. I mean, we can also visualize this with RMC. So again, here you can see the relative mean square error per day for temperature. And ideally, this should be 0, right? To have the perfect forecast. But again, you see that that's not very good. So let's try running now in parallel. So using sharding now, we are running again for both of locations. And again, think about our needs are like we're going to have thousands of weather stations out there. We wouldn't want to run the computations on their data sequentially. Ideally, we would like to run batch jobs for huge amounts of data because this is just a sample data set. When we start adding GRIB files, the global forecasting files that are gigabytes of data every day, it's going to be hard. So we need parallel computations. No, okay, so let's get this job. So here you see that the computation run now in parallel, and we have the results of both location, Lisbon and Mansfield. And let's check Mansfield, I guess. And again, you see something similar, but no. Let's try also the rain, or no, wind speed. So wind is even more difficult. Wind is one of the more chaotic phenomena. So again, you can see some models like the blue line is really, really off compared to what happened in reality. And we've seen this in many projects that we've done, which affect, let's say, the wind turbines. You need to know the wind speed there in order to know how much output they will produce. So it's a big pain for the energy industry not being able to predict the wind correctly. Okay, so I think we should close now. Thank you very much. And just a final note, because people have been asking us throughout Lab Week that half of the team is here. Where can we buy one of your stations? Right, I forgot to show it. Thanks, Manolis. So this is one of the stations. This one is not officially out yet. You can pre-order it. We'll be launching this like in a month or so, yeah? So this is the helium version. It's standalone. You can just put it out on your balcony, and it connects to the helium network. And we put up this form in this URL for people here in the COD Summit. And you can just skip the invitation queue by subscribing today. Thank you very much again.